And thank you for coming to this presentation. I'm Andrei, and I will talk today about automation, open source, and security. I want to start with a little story, a story about an economic jungle. In this jungle, there are multiple animals, and the lives of these animals unfolds. They differ in multiple characteristics, namely number of employees, revenue, business model, and security posture. But in difference to the mighty jungle in which the lion sleeps, here the predators are alive, are awake, and are hungry. But in difference to the mighty jungle that we already know, here the predators doesn't sleep. They doesn't want to kill other animals. They want to steal their resources. And the explanation here is that if you have a damaged animal, they will heal themselves and they will produce other resources, and you can hunt them later. In this graph, we can see that the percentage of the IT budget that is allocated by each company in security. And I will say a no-brainer, but if you multiply this percentage with the IT budget, we can determine that the security budget for small companies is less for small companies than for the big ones. And in addition, the percentage of this budget that can be invested in IT, for example, for the evolution of the IT infrastructure is less for small companies than for the biggest one. The biggest one. And in this jungle that I already presented, there are two types of animals. There are two types of animals. Here we have Google-like elephants, and we will see that are zebras too. To give you some numbers about these elephants, we can talk about Google, and they have three-digit billion dollars revenue in 2021. In addition, they own 10% of a multi-billion dollar industry, cloud industry. But to come back to the security part, we have this playlist, this awesome playlist that Google published 1 month ago, in which they described their evolution since 2009. Then they had this Operation Aurora, in which the Chinese people broke their infrastructure and wanted to steal their information. And since then, they invested a lot in their infrastructure, the infrastructure that is shared with their clients. And to summarize the characteristic of this type of animals, we can see that they have the budget to invest in best-in-class cybersecurity solutions. They have SOCs in-house or outsourced to other MSSPs. We have in-house pen test teams, threat hunting teams, maybe bug bounty programs in which they can pay other people from the internet to hunt their vulnerabilities from systems that are exposed on the internet, and hard usage of configuration management. And this is because they have a lot of specialists, and these specialists can learn domain-specific languages like Ansible, Chef, or Puppet. On the other hand, we have zebras. And here I want to invite you to make an imagination exercise and think about this small IT outsourcing company. And let's name it Zaga Zaga. To give you a little glimpse into what security at Zaga Zaga means, we can see this gig on Fiverr. This guy, for 42 euros, will install Vazoo, which is an XDR NCM, and its agents, and audit do. Zaga Zaga will benefit from an offer like this because they don't have the specialist to invest in this kind of projects. And to give you a list of the characteristics for the Zaga Zaga like Zebra, we have open source or entry-level solutions because they don't have the budget to invest in other security, in other modern security solutions. They own few security specialists or none at all, and they do a lot of manual work because of the lack of the expertise and the lack of the time. At this moment, you may ask, but Andrei, I came to this presentation to talk about open source. What's this Zaga animal? What's the link between these animals and your open source program? And to respond to this, we want to target with mutable security the animals that are the most vulnerable in this jungle. Mutable security is a platform for automating the automation to automate the setup, configuration, and management of cybersecurity solution. You can think of this as a tool that can be used by IT and security professionals with small or medium infrastructures to deploy cybersecurity solutions, to configure them initially, and after that to test them, to further configure them, to monitor and to update, and if it is the case, to uninstall them. At the moment, we published this open source project on GitHub, and we support only Linux virtual machines. In addition, there are multiple cybersecurity solutions that are implemented as modules in mutable security, namely Teller, which is a web intrusion detection system, Fail2Ban, which is a host IPS, Suricata, which is a network intrusion detection system, Certbot for generating SSL certificates, Clamavoo for detecting malware on operating system or Linux operating systems, and Vector for shipping logs to Grafana. In addition, we have two more modules that are work in progress, namely Duplicati for generating and restoring backups, and Vazoo, which is the CM and XDR that I previously mentioned. And to switch to a realistic scenario, we will try to hack and defend Zaga. In this C4 diagram, we can see that there is a server that hosts a website. This server basically serves some pages to the real users of Zaga. In addition, we have a remote access server, an OpenSSH, that lets a privileged user to access the website and administer it. And this website and server, as it is exposed on the internet, will be attacked by some random guys on the internet who hacks all the things that are vulnerable and insecure. Let's suppose that this IT administrator that deals with the security and the infrastructure at Zaga discover mutable security. What can he do? In the infrastructure before, we doesn't have these cybersecurity solutions. There is a web IDS that will detect the attacks on the web server. We have this host IPS that will inspect the alerts that are generated by Teller, and in addition will monitor the remote access server and will block the attackers. The third solution that we can install at this moment is the log shipper, namely Vector. It will collect the logs that are generated by the host IPS and the web IDS and will ship them to a Grafana cloud instance that will store the logs into a Loki instance and will display them in dashboards using Grafana. And to switch to a demo, a little observation here is that we have two types of slides. The first type is a red one, in which we are in the shoes of an attacker, and there are purple ones, in which we can think about ourselves as IT administrators at Zaga with mutable security in our hands. The first step as an attacker is to discover the website of Zaga on internet. Yeah, I'll stay here. As you can see, the attacker will visit the pages that are available on the website by clicking these random buttons on the website. And as we can see, the last part of the URL with this view parameter is changing. And you may think about this as a path. And we will see later that there is a local file inclusion vulnerability involved. After this information, we can switch the attack to a scanning phase, in which we will use Nmap with two flags, namely SV and SC, for scanning the server that is exposed on the internet. SV and SC are used for letting Nmap to scan with the default script, and the other is for banner grabbing. And we can see that there are two open ports here, namely the OpenSSH and the Nginx one. We can validate afterwards the local file inclusion vulnerability by making a curl with the // and an etc machine ID. And we can see that in the response there is also a hash that identifies the virtual machine. After that, we can check if an SSH whitelisting mechanism is involved, and we will see that none of this is enabled. Yeah, we SSH, and we can see that the random password that we introduce is invalid. So the remote server will respond to any user from the internet. We can automate this with a Python script with 4 functions. The first 2 are for checking if the LFI is enabled, and the other 2 for iterating through a dictionary and brute force the SSH server. After running this, the HTTP request is done, and we can see that the root entry is found in the exit password that is returned in the content of the page. And after that, some credentials are reported as invalid, but after this dummy password, there's password, parola, pass, the valid one is detected. After this, we will switch to the shoes of a defender, which will use MutableSecurity to install cybersecurity solutions. At first, we want to install Teller, which is the web IDS. At this moment, we run MutableSecurity, and we can see that multiple solutions are available, namely Suricata, Fail2Ban, etc., and some operations. In this screen, we can see that there are multiple objects implemented, namely actions, informations, log sources, and tests. But we are interested at this moment to configure the solution with the init operation. A file is generated, like in Kubernetes, and we can change this with the values that better represent our infrastructure. We then use the install operation, and after some minutes in which the executables are retrieved from the internet and the solution is installed, we can use the get information operation in order to retrieve the configuration that is set to the security solution and some metrics about its functioning. The next operation involved is testing, namely executing a battery of tests against the solution that we installed. And in this table, we can see the identifier, what the test was about, and the value that represents a Boolean, which states that the tests are executed correctly. We can see here the logs that are produced, and then we switch to Fail2Ban in order to detect and block SSH brute force. As previously, we use MutableSecurity at this moment with the -s flag with Fail2Ban as value. We can see its objects. And with -o init, we generate the initial configuration. As previously, the values that are already there, the default one, are okay for us, and we can use the install operation. After some seconds, the solution will be installed. And we will use the get information in order to see its configuration and metrics. In this case, for example, the jails that are enabled in fail to ban, the ban seconds, the banned IPs, etc. Then the test operation is used, the same battery of tests is executed, and we can see that all of them are passing. And the get logs operation with -E for specifying the identifier in order to see the logs that are exposed by fail to ban. We switch to the attacker position, and we will observe that we will get banned after some requests. The LFI is still available, but the brute force fails. Okay, now we want to unban an IP, namely to use an action that is exposed on MutableSecurity. We use -S fail to ban with the get information operation in order to see the banned IPs, and we can see 2 of them. And now I switch to an IP geolocation in order to see what the second IP is. And yeah, this is my IP. And another random guy on the internet who, in like 3 minutes, wanted to brute force that SSH server that is exposed on the internet. Okay, coming back, we unbanned that IP. As previously, we use fail to ban in order to see the exposed objects. We'll use the -O execute after this operation. Yeah, we can see the 2 IPs that are blocked at the moment here. And -O execute with the -E identifier with unban and a list of arguments, namely the jail name, which is SSHD, and the IP that we want to unban. After running this operation, we can make requests again. Yeah, we now try to integrate the teller that is able only to detect web attacks with fail to ban, which is used to block an attacker. For this, we can use an information that is exposed on MutableSecurity, which is fail to ban integration, with -S teller, -O set information, and the identifier of that information, namely fail to ban integration. And we set it to true. In some moments, it will pass, and we switch to the attacker position and try to execute in the LFI again, and getting banned. Here I used a for loop, and after some requests, teller will produce the logs for this attacker, and fail to ban will retrieve them and will ban the IP. We switch back to the defender position, and now we will install Vector, which is a log shipper developed by Datadog, which will retrieve the logs that are produced by fail to ban and teller, and send them to a Grafana instance in cloud. As previously, we use -O init for initializing this, but as the default configuration is not good here, I just use another file from from the disk. And here we have things like the endpoint, a token, and a user. And at the top, a list of the enabled solutions, namely fail to ban and Teller that we previously installed. It will be installed in some seconds, and after this, we can get its information. And testing it. We can go to Grafana in this moment. And in the log sources, section, we can see that log key is enabled. We can test that the labels can be retrieved. And in the explore section, we can set the label for source and the source of the logs, namely fail to ban logs in this example. And we can see that in the last minutes, the logs from fail to ban were sent. And the same thing for Teller. After all of this, I wanted to let this virtual machine on the internet 24 hours and see how many random guys on the internet wants to brute force that SSH server. And there are multiple, as you will see. With the get information operation, we can see that this is the list of guys from the internet that wanted to brute force it. Coming back to the presentation, I want to end with some security mechanisms that we used in MutableSecurity to defend our code base. To give you a little information about how we developed this, we have as the main programming language Python, and as for automating the operations that are done on the remote servers, we use PyInfra. Here, the advantage of PyInfra is that it is Python basically. Namely, you can call a function in Python, and some operations are executed instantaneously on the remote server. In addition, we have Firebase, React.js, Cloudflare, GitHub, some GC from GCP, and another security mechanisms that I will describe. The first service that we use is the Bentabot. Basically, you take your repository from GitHub, for example, and install the Bentabot on it. And this bot will watch your dependencies and will create pull requests once another version is available. We recommend here to integrate with your unit testing because there may be some huge differences between versions, for example, the major ones. And you want to detect this in order to not affect the functionality of your application. In addition, we used DeepSource, which is another SaaS. We linked the repository, and they will do some static code analysis, coverage, and creating automatically pull requests for issues that are detected by them. And lastly, we use PyTest for creating the unit test that I previously mentioned. Only for the core API, it will be nice if in the future we can create the unit testing, but for security solutions. For example, if there is another version of Suricata that is published, we want to detect if some flags on the CLI were changed in order to let the MutableSecurity users to not be affected. To switch the presentation to future, we want to create a marketplace. At this moment, there are multiple security solutions, each of them with its own documentation, its own interface, and we want to bring all of them under a standardized umbrella to learn only a tool, namely MutableSecurity, without learning the documentation and the usage of each security solution that you use. As I previously mentioned, we only support Linux virtual machine, but it will be nice if we can deploy to other infrastructures, for example, Kubernetes and Docker. Yeah, how you can help? First, we bring some beer, and here are and I want to apologize to the DefCamp team, but yeah, we have beer and we want to talk with you after this presentation and to hear your opinion about this project and how we can do this better. In addition, there is this saying that one man's GitHub star is another man's treasure. So you can have, if you have a GitHub account and you like this project, just drop us a star there. We'll appreciate it. We'll appreciate it. And to finally thank to the team that make all of this possible. Here is the members of MutableSecurity. Firstly, Aline, which is a core developer and student. Ionuț, which is a cybersecurity student, pen tester and core developer. Jay, XB Defender, and now CISO at Superbad Group. And I give him many thanks for letting me be the second person in DefCamp, who uses this AI-generated content. And Marius, in our startup endeavor, he is the chief operating officer, and I was Andrei, the leader of this team. Yeah, that was it. Thanks.
Thank you, Andrei. Thank you, Andrei. Ooh. So that sounds like a really cool project. Besides that, do we have any questions in the audience? Yes, we do have questions in the audience. Perfect.
Oh, quite impressive project. Quick question. Yeah. Quick question. What kind of organizations do you see as being the primary targets or the primary users for this system?
At this moment, we want to target a small organization that doesn't have the budget or the personnel to invest in more hardcore operations. For example, installing cybersecurity solution and managing them with Ansible and Chef and these automation languages that are available in the market. Thank you too.
Do we have other questions in the audience? Yes. Let me lose weight in that direction.
Hello, everyone. Thank you for the presentation. Thank you. I was curious, what other integrations do you have in mind for the roadmap? Like, for example, have you thought about integrated sync?
Can you repeat the solution, please?
What other integrations do you have in mind in your roadmap?
At this moment, we developed some modules that are already available on GitHub, but we want at this moment to validate, namely to post, for example, on Reddit, on subreddits, or publishing to LinkedIn groups, in order to validate that there is a need for this kind of solution. And regarding your question, we don't want to establish a roadmap without any further validation. Yeah, it will be nice to integrate, for example, Kubernetes solutions, but there is a need. We need to answer this question first.
Also, there is a project on GitHub that is searching for vulnerabilities and in the repository dependencies sync, it's called. Okay. Maybe you want to check it out.
Mm-hmm. Sure. Thanks.
Thank you again.
Thank you.
Awesome. Any other questions? Yes? No? Okay, let's move on. If there are one more question, perfect.
This one? Or this one?
This
okay.
one. I was wondering, The architecture seems okay. It's just not clear to me why the IDS is sending log inspection to the web server while the log shipper sends it to the IDPS.
No, basically the IDS will watch the logs that are produced by Nginx, and based on these logs, Teller will generate other logs that are alerts, and these alerts that are produced by Teller are then passed to the host IPS, fail to ban. And when multiple lines are generated for a single IP address, fail to ban will ban the IP that generated that alert.
Yeah, I understood that, but that's not what the architecture says. It says the IDS is sending inspection logs to the web server.
Yeah.
But not to the IDPS?
Yeah, the IDS watches the logs that are produced by the web server.
So the arrow should be from the web server to the IDS then, right?
Not really. This is the C4 convention. I respected it and...
Okay, I misunderstood it then. And the second one, this is just out of curiosity. Did you check out the IPs of the random guys?
Yeah, I actually plotted them on a map, yeah, and there were 5 guys from China, 2 from Russia, 2 from UK, and other corners of the world.
Okay.
Yeah.
Did you check if those ISPs were ever spotted doing attacks or reported as, I don't know, malicious in any way?
Not really, not really.
Okay. You mentioned that you had in mind integration with Wazoo. Do you want to tell us more about that? Because I would be interested in that, for example.
Yeah. We already integrated Wazoo in a previous version of MutableSecurity, but we changed some aspects of the API. How it will work, there will be 2 modules for Wazoo, namely one for the manager and one for the agent. You will install first the manager. He will expose some API keys, for example, to let the agents connect to the manager. And afterwards, you can install the agent on the servers that you want to monitor.
Do you want to monitor only web servers, or are you planning to take logs from other sources as well?
At the moment, we target only Linux servers, not especially web ones. But if there is a request to implement Windows security solution, for example, we will do that.
Okay, thank you. Thank you so much for this presentation. I think it's a cool project, and if you want to work on it, I think it has some really ups, and the first one is the price, obviously, because there are a lot of free solutions. However, the work that you need to do in order to make everything talk to each other. It's not that easy. Thank you so much, Andrei.
Thank you for having me, and we have beer. Yeah, if you want to talk with us about this and automation and open source, you'll recognize us by the t-shirts. Yeah, thank you.
Thank you.